This new playlist is all about generating functions and its particular application into the combinatorics. So we're going to talk about some of its important concepts, but to start with, let's talk about ordinary generating function. This is one of the types of generating function that we can draw some relationships with regards to the counts later on, as some of the terms after we generate a certain function will determine the coefficient of certain x to the power of n or certain literal coefficient in the said function. Let's define here in this manner. Let you have here sequence a sub n containing a sub 0, a sub 1, a sub 2 until a sub n be a sequence of numbers. Then you have here the corresponding generating function for this. Let's say f of x for the sequence a sub n is defined to be a power series. Okay, power series in this manner. F of x is equal to your first element in your sequence would be the constant here, plus your second element or your a sub 1 is the coefficient of your x to the power of 1, plus a sub 2 x squared, plus a sub 3 x cubed, until you reach a sub n x to the power of n, and so on and so forth. Okay, take note that we can also express here x to the power of 0, hence a to the power of 0 times x to the power, a sub 0 times x to the power of 0 is again a sub 0. That's your constant there. Now this generating function can be defined as a power series, the summation of your a sub I x to the power of I. Noticeably, we have the same exponents here. So you have a sub I x to the power of I, where I starts from 0 to positive infinity. Okay, so this is how we derive a generating function. Later on, we'll be given with a sequence, and we are tasked to provide a generated function that will stand for the said sequence. So we simply take out the terms of that sequence, pair it with x sub i's, and then later on we will have ordinary generated function. Take note, we are still on ordinary generating function here. Before we end this video, it's important for us to note, as mentioned earlier, a sub n, which is paired to the power with the little coefficient x to the power of n, being considered as the nth term of the sequence, is the coefficient of x to the power of n. And in the concept of combinatorics, it is actually, or it has a important implication to that, as to a sub n being the coefficient of x sub n. We'll talk about that for some few examples later on. So this is how we define generating function, especially ordinary generating function, because we also have a different definition for other forms of generating function. Thank you very much for watching.